In this video we'll go over quadratic modeling. Quadratic modeling is just a fancy term for word problems with quadratics. Alright, here's an example of a word problem where you would end up using a quadratic. It says the marketing department at Texas Instruments has found that when certain calculators are sold at a price of $P per unit, the number X of calculators sold is given by the demand equation. X equals 21,000 minus 150 times the price. Find a model that expresses revenue solely as a function of the price. Alright, for part A, if you think about it, revenue is equal to the number of calculators, which I think they use the letter X for that, the number of calculators multiplied by the price per calculator. So if you notice right here, we have a formula for the number of calculators. So if we substitute that in, multiply it by P again, that would tell us that our formula for the revenue solely in terms of the price would be, if you distribute 21,000 P minus 150 P squared. Or if you want to put the P squared term in front, plus 21,000 P. Now for part B, normally since we have a quadratic we just write the domain as all real numbers. However, since our X represents the number of calculators sold, we can't sell a negative amount of calculators. So, our X must be greater than or equal to 0. But we have a formula, but our function now is no longer in terms of X and P right here. It's now solely in terms of P. So why don't we plug our formula in? Our 21,000 minus 150p is greater than or equal to 0. So if we go ahead and try to isolate the p term, we would have negative 150p is greater than or equal to negative 21,000. So the price must be less than $140. So the domain, since it's in terms of p, would be the set of all prices such that the price must be greater than 0, or greater than or equal to 0, and it must be less than or equal to 140. You could also write strictly less than. 0 is less than the price, since Texas Instruments probably will not be giving calculators away for free. Now for part C, it asks, what unit price should be used to maximize revenue? Alright. If you remember, we have a downward facing quadratic because the number in front of the p squared term is negative, so that's how you know it's facing downward. So the vertex would be a maximum value, so we need to find the value of p that maximizes our quadratic, and that would tell you the price that would maximize the revenue, the price per calculator. So the formula for the x part of our vertex is just negative b over 2a. That'd be opposite of the number in front of p, which would be 21,000, all over. It'd be 2 times a, which so would be negative 150. We can change that to p, because I imagine that's probably kind of confusing. The price per calculator. So that'll tell you the price per calculator that would maximize the revenue would be $70. And this formula here, negative b over 2a, that just gives you the x coordinate of the vertex. So you don't have to do completing the square on a quadratic. Part D, if this price is charged, what is the maximum revenue? To do that, you just plug in 70 for p into our function. Negative 150 times 70 squared plus 21,000 times 70. If you go ahead and simplify all that, you should get that they have a maximum revenue of $735,000. Okay, in part E, asks how many units or how many calculators are sold at this price. Remember, it's equal, the number of units sold is equal to 21,000 minus 150 times the price. So it'd be 21,000 minus 150 times 70. So the number of calculators sold would be 10,500. Now for part F, to graph R, if you're doing it by hand, you would just need to, first of all, you would need to plot the intercepts. Remember, the intercepts are 0, 0, but remember that's with an open circle because they would not be giving the calculators away for free. Now let's plot the other intercept, which would be at 140, 0, and then the vertex of 70 and 735,000. If you were to do that, this is what the graph would look like. Right here, this is what the graph looks like. Now for part G, it asks, what price should Texas Instruments charge to collect at least $675,000 in revenue? Alright, to illustrate this, you would, if you want to look at the graph, it would just be, alright, you go to 675,000, which would be that silver line. I'm not even sure you can see it very well. I'm going to use a darker color. Something like that. If you notice, at 675,000, the prices that would give you equal to that would be right there. So it would be any X value from here to here would give you a revenue of at least $675,000. So we need to figure out the X values that give you at least, or the prices that give you that revenue of $675,000 equal in. Any revenue in there will give you more than that. So we have the negative 150 p squared plus 21,000 p. We're going to find out where it equals 675,000 first. So if we get everything on the same side, you have 0 equals, if you move everything to the same side, you should have this quadratic 150p squared minus 21,000p plus 675,000. I would recommend factoring out 150 because that would give you p squared minus 140p equals 4,500. So since 150 can never be equal to 0, we can just solve this quadratic. Solve that quadratic, and the factors of 4,500 that add to give you 140 would just be 50 and 90. So we can rewrite this as just p minus 50 times p minus 90 is equal to 0. So that means in order to get it exactly $675,000 in revenue, they should charge $50 or $90. But since we want at least that much revenue, that means that they should charge between $50 and $90 per calculator to get at least that much revenue. Alright, here's another example. A farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Alright, there are a couple formulas you'll need to know. The first is the formula for the perimeter. The formula is twice the length plus twice the width is equal to the perimeter, which in this case is 2,000 yards. And area is equal to length times width. So, what we're going to do is we're going to take this formula here and solve it for one of the variables. Let's go ahead and solve it for the width. So, if you were to do that, you'd have 2W is equal to 2000 minus 2L. If you get the 2W by itself, which means W, after you divide everything by 2, would just be 1000 minus the length. So what you're going to do is you're going to take this and plug it in here to W. And that would give you a formula for the area. It'd be length times 1000 minus the length, or negative L squared plus 1000 times the length. Let me write that neater. Our formula for the area in terms of the length is equal to negative L squared plus 1000 L. Now, what we can do is take the formula for the maximum value. Since it's a negative in front of the L squared, you know it faces downward. So, the formula for the x-coordinate of the vertex, which in this case would give you the maximum, is equal to negative b over 2a. Remember, b is the number in front of L, so it'll just be 1000. And a is the number in front of the L squared, so it'd be minus 1. So, the dimensions for the length would be 500. So, to find the dimension of the width, you would plug it in up here for the formula for the width. Alright, so the width, you plug it into that formula for W that we had, the 1000 minus the length, and that gives you the width, would also be 500. So, the maximum area would just be 500 times 500, which would be 250,000 square yards. And whenever you have a problem like this, where it's maximizing the area of a rectangle given the perimeter, your answer will always be a square. Just keep that in mind. Alright, here's the last problem we're doing in this video. Alright, it says a projectile is fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. In physics, it is established that the height of the projectile above the water can be modeled by negative 32x squared over the velocity squared plus x plus 500, where x is the horizontal distance of the projectile from the base of the cliff. And see figure 27. My first question is find the maximum height of the projectile, and the second one is how far from the base of the cliff will the projectile strike the water. Alright, so for part A, it might help if you go ahead and simplify the leading coefficient. Alright, this negative 32 over 400 squared would just be negative 1 over 5,000, and x squared plus x plus 500. So remember, the formula, since it's facing downward, the vertex would give you a maximum. The formula for the x-coordinate of the maximum of the vertex would just be negative b over 2a. So it'd be negative, and then the number in front of b is, the number in front of x is just 1. The number in front of the x squared would be negative 1 over 5,000. So if you want to simplify that, the horizontal distance it will travel whenever it reaches its maximum height would be 2,500 feet. So now to figure out the maximum height, you plug in 2,500 into your formula. Negative 1 over 5,000 times 2,500 squared plus 2,500 plus 500. And using my mental math skills, that give you a maximum height of 1,750 feet. And yes, I did do that in my head. I totally do not have the book in front of me with the answer in it. And for part B, it'll strike the water when the height is 0. So you can take that quadratic, negative 1 over 5,000 x squared plus x plus 500, and set it equal to 0. Before we plug it into the quadratic formula, it might help if you check the discriminant just to make sure we didn't do anything wrong. Because if the discriminant is negative, that means we probably did something wrong in the previous example. Remember, it's b squared minus 4ac. So it'd be 1 squared minus 4 times negative 1 over 5,000 times 500. So that means the discriminant would be 1.4. That means we do have 2 real roots, one of which will probably be positive. So we can go ahead and plug it into our quadratic formula. It'd be negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so it'd be negative 1 plus or minus the square root. Now this b squared minus 4ac is equal to 1.4, because we already worked it out. And then 2 times a, so it'd be 2 times negative 1 over 5,000. Now if you want to simplify this, that would tell you that the horizontal distance it travels is either approximately negative 458 feet or positive 5,458 feet. Since it cannot travel a negative distance if it's going forward, we ignore the negative answer. So it traveled a horizontal distance of 5,458 feet.